This is a troubleshooting video. We had a storm last night. It knocked out our power, which in turn, when the power came back on, our air conditioner did not. So we're going to troubleshoot this air conditioner and see what's wrong with it. So this is a 1.5 ton air conditioner. So the first thing you want to do is get a picture of your model and serial number in case you have to order parts. Okay, so the next thing I would do is typically is throw the power off, but in this case I'm going to leave it on because most of the computers now have a circuit board in there, and they'll have a code that's latched similar to what you see on your OBD2 or 3 on your truck or vehicle. And so it'll be trying to tell us a little something. So like I say, don't do this if you're untrained, because this is 220 volts, 240 right here, and you could die. So even taking that cover off, make sure you don't let it fall back into the electrical. Okay, first thing I do is I look at the wiring. And again, this is hot, so be careful. But none of the wires are burnt around the contactor. This starts the compressor and the fan. Here's the run capacitor for both the compressor and the fan. And this is a heat pump, so we got a circuit board to control, makes and breaks at 24 volts. And that looks like the fan speed control. So this model is extra quiet, has 2 speeds on the fan motor. Another thing that's helpful is you look in here and you see the diagram, wiring diagram. Okay, so it's telling me, it's giving me 3 flashes there. And if I look down here, 3 flashes, 3 yellow flashes is short cycling, which we already know that there was a problem there. So I know that the fan motor, because I come out here in my underwear last night, I know the fan motor is not starting. So here's a good test. When you have a fan motor with the power off, which this is on, but I know what I'm doing. So what I'm going to do is gently turn the fan. Do you see how that rocks real easy? See how slow it is to stop? That means the bearings are good. So there's nothing wrong with the mechanical side of this fan. It definitely spins very easily. That's what you want. Most of these fan motors now are sealed bearings. When I first started, everything was oil. That was back in the 70s. Now the next thing I'm going to do is check that fan motor again to make sure I saw what I saw, which is it's not spinning. So what I'm going to do is there's a way to energize this coil or energize the starter without energizing the coil, and that's just pushing the contacts in to make up. So what I'm going to do is push this in, and I'm going to look at that fan motor. So the compressor came right on, and so did the fan. Okay, so right now there's no problems. So that makes this troubleshooting even harder. So now we're going to have to let it, what I'll do now is let this equalize, the pressure in the system equalize, and then we'll call from it, then we'll call for cooling from the thermostat and see what happens. Okay, so when we made it call from the thermostat, the fan came on, no problems. So what I'm going to do now is I'm going to check the low speed fan. So this is the power, this wire right here is coming off the starter, see? Runs up to this relay here, and then that power is diverted down here. When it calls for the fan, powers this circuit, and we got high fan and low fan. So what I'm going to do is check out low fan, since we just saw the high fan work as it should. Now this relay right here could actually be bad and be part of the problem. But since it's working, it's harder to figure out what's wrong. So what I'm going to do now is I'm going to power up the fan only. This is low speed fan. So what I'm going to do is come down here. You have to be really careful. Here's the power wire, and I'm going to touch it to, if it'll reach, I need to touch it down to the line side of that contactor at the bottom. Here we go. We'll see if the fan comes on. So the high speed and low speed should never be energized together, but because all this circuitry's off, the unit's not being called for right now, I can do this without, well, hopefully I can do this without any sparks coming out of here. Okay, I just powered it up, and the fan is not working. No bueno on the low speed. So what I'm going to do is put this back so I don't lose track of where things go. Of course, we have the wiring diagram. And what I'm going to do now is this black wire. Okay, I'm going to show you what I did last night at 10 o'clock to get a little air conditioning or to help cool the house down when I come out here and heard the fan humming. And sometimes you can get lucky and turn the unit down really low, get the fan running, turn it down really low, cool your house down, then turn it off. So here, so the fan, I've got it, what I'm going to do is just energize the fan and not the air conditioner, not the compressor. So I'll show you what I looked at last night. So that fan's humming, and it would overheat if I left it like that. So what I did is real carefully took a yardstick and spun it. Now you see that it's continuing to spin. Now the next step is I'll have to figure out, is it the motor or the capacitor? So we'll take a look at that. But see how it's just continuing to spin? Now here it comes. So I can already tell that the motor's bad just because of the way it sounds. But we'll continue on. Okay, the unit's calling for cooling. The fan is cranking up. Uh-oh. It's drawing an amp, and I just heard the sparks flying inside the motor. So this is going to be a no bueno. We're not going to be able to keep this running. So what happened was that low speed winding shorted, and it caused a problem with the high speed winding. See, it's 25, a quarter of an amp higher than it should be right now. Okay, the air conditioner's been running 4 or 5 minutes. I decided I'd let it run for a little while, and I'll check to see what kind of heat we're building up on that motor in there. If the heat is not too high, I may leave it on, but this motor will fail, and the risk I run with what I'm fixing to do is, if that motor fails and I'm not here, then the compressor will run, and it will generate high pressure because air is not moving across the coil to cool it down. So pressures will build up, and this is R410A, so it's going to be 500 pounds or more, I bet. So we'll let it run for 10 minutes or so, and I'll pull the top, and I'll check the temperature of that motor. If the motor's cool, might let it run. If I can't put my hands on it, we're done. I'm gonna have to order the part anyway, but we're a long ways from help here, so it's gonna take a while to get it. Okay, so we've been running 10 minutes, and I'm gonna check the temperature of this motor before I get off of here and go order a motor. And what I'm gonna do is just to see if I can even limp by it all today. But I can tell you that I can smell the windings burning here. The windings be inside the motor. Insulated wire, let's say. So we turned her off. What I'm going to do is stop this fan rotating. And don't try this at home. Okay, the wires are coming back this direction. It's I'm going to lift it this way. I'm going to be real careful here. Okay, you can hold your hand on 150 degrees, and that's more than 150. So that's no bueno. So now the next step I'll do is I'll actually get the numbers and the information off of this motor and order it that way instead of ordering through the model number. I want to make sure I end up with an exact replacement. And many times you'll replace the capacitor too. So we're going to have to end this video. I'm going to have to go order this motor. Okay, so it's been 10 days, believe it or not. We ordered the fan motor on Tuesday, a week ago, and they said it would be 3 days or whatever, 5 days. It didn't come in. So it took 10 days for the motor to get here, and I just wanted to go over real quick. Camera girl's filming right now, and she told me that I need to talk about some of the safety violations that I performed while working on this. First off, let me just say I have a degree in air conditioning that I got when I was a young man, and I've worked on air conditioners from the country all the way to the big city, high rises, from little bitty small units like this to chillers, 100 tons or better. And I worked offshore on air conditioning, so a lot of experience working on low voltage all the way up to 480 volt secondary voltages. So a lot of the things I did on this air conditioner with it hot, with the energized breaker, were unsafe. So just wanted to give that disclaimer that you can do similar things to what I did here today or in the last few days without having it energized and then throwing the breaker on to test it. Because I was comfortable with the voltage, I did it the way I did it. It's not safe. So we've got the fan motor, and I'm just going to go over real quick. When you go to order a fan motor, like I showed you about the bearing, you want to make sure your bearings are good. This one's a ball bearing. It's a very good motor. This motor costs $200. And when you order a motor, there's universal motors I could have gotten quickly. Look at there. The wire's already boogered up from the factory, so I can put some tape around that. But this is what you call a 48 frame. All electrical motors have a frame. That's the way they mount. So this one's going to mount in here just like this, with the fan down here. Some fan motors are mounted like this, and these bolts are turned around and coming up this way, or the bracket has a bracket in there. It mounts to here or here. And a lot of times when you have a vertical shaft like this, you'll have to have a rain shield also. So if your fan has a little plastic plate underneath it, and maybe sometimes it'll be busted up, it fits snugly around this 1/2-inch shaft, and it keeps the water or the rain from falling down into your bearings. So if you order your motor, make sure you don't need a rain shield too. And the one thing I wanted to point out was during the testing you heard some sparks, and after that this fan, this whole motor started shaking after those sparks occurred. So some crazy stuff happened with the winding. So we're very, very lucky that we were able to keep this running. And again, the way we did it is, what did we do, camera girl? We put the thermostat on 65, and we'd run this thing. I'd spin the fan blade, it would run. We'd get the temperature down to about 69 or so, and we'd just turn it off. And then we wouldn't turn it back on without me coming back out and spinning the fan and doing that process. That's how we survived 10 days. The other thing is, when you're doing this, I didn't show you this earlier, but the heat is removed by the coil here, and the heat, when you grab your liquid line, the freon's flowing out of here toward the expansion valve inside on the indoor coil. This shouldn't be very hot. Your coils are clean. This will be, like, you can barely tell there's a temperature here. It'll just be ambient. And our ambient's around 90 right now. So that's saying 98. So it's a 10-degree rise, let's say. 10 to 30. I would say if you're getting close to 30, you may have either the sun hitting your coil or it's dirty. But because you can grab this, getting back to our problem here, this fan motor is not moving as much air as it normally should. But by grabbing this, I know now that it can keep running. From here on, from here back into the house, there's no problems. The indoor unit doesn't know there's a problem because the temperatures are correct here. So that was another thing I should have said the other day when I was checking this. So just got real lucky. The crows or some bird, every time they get ready to build a nest, they chew that off of there. So now all that's left to do, so I'm gonna pull this out and we'll check the temperature of that motor. Well, I can do it right through here. So the motor is 152. The air conditioner just cycled off. So I got lucky that the motor didn't overheat completely. It's hot, but it didn't overheat. So the other thing I want to make sure everybody understands is I wired that fan motor direct so it would continuously run. So if it did happen to cycle, the fan would never cycle, just the compressor. All right, let's take it apart and replace this fan motor. Okay, right off the bat, I see where I was a little bit wrong. I thought the shorting of the windings caused an imbalance, but when I look here, I guess during one of the periods of being shut down, a dirt diver came in and rebalanced my fan blade for me. So the fan, since it's a direct OEM replacement, comes with a plug. If you were doing a universal, that would not be the case. So this is a pretty straightforward replacement. But if you were putting in a universal, if you had to go with the universal, make sure your RPMs match or exceed. Now if you exceed, you're going to have more noise and you may have other problems. I mean, I've done it when you have to, but try to get back to your OEM. I was never trained to bypass safety controls or anything like that. I was trained to put it back like the customer paid for. So here are the fan wires, and no, here's the fan wires right here. So I'm going to unplug this. Okay. So you note the orientation of your fan and also where it is on the shaft. This is going to be easy because this fan hub is sitting right at the end of the shaft. So if you drop that fan down or up, you can change the airflow across your condenser coil. More than likely it'll go down instead of up. But you need to pay attention to that. Take a picture of it before you take it out. Like, you can even look and see the shroud under here, how far the fan is from the shroud. But since I'm going with OEM, I don't worry about that. I got the exact motor. I put it back just like I found it. Here's the little buddy right there that was causing the imbalance. And like I say around here on the Triple T, we're always under attack. But the fan blade is good. If it was rusted, I'd probably get another one, but this unit is it's only been, I installed this in 2013, I believe. So all I've got left to do is pull this cap off of this grill, pull that motor out and put the other one in. So I'm going to go off camera, put the new one in, and then continue here putting it back together. Since this is a ball bearing motor, it's completely sealed, no oilers. No way to oil it, and I'm glad. Now if you had swapped this motor around, the end caps, you can swap them around, whatever you need to do to get a universal or another different type of motor installed. You want to make sure you do that test right there. You want to make sure it comes to a real gentle stop. Alright, here's black on this corner, black on that corner, brown, yellow, they all match up. So that's that. Just got to bundle these wires up now. What I'm going to do now is I'm going to take a look at this contactor, because this unit's been in, so I think it was 2013, so 8 years, let's say, at least 7. So it's very possible this contactor, the contacts on there, there's silver contacts on here, they're probably pitted. And if that's the case, this is a good time to go ahead and replace those. Okay, so I replaced the starting contactor, starter, whatever you want to call it. This is a 30 amp, and this was a 30 amp. This was the original. The difference is, see this where it says shunt? That's not a contact. That's just a straight shot across there. So this has been working for 8 years, around the clock, 24/7, carrying all the load across one single contact. So as I said before, I go back with OEM, but in this case I'm going to upgrade a little bit. I got 2 contacts there that'll carry, that'll divide the load across those contacts. So everything is still the same, 24 volt coil, all the connections are the same as this one. You just have an extra contact. And I picked this up, I want to say I paid, it's been a while, but $20, $25 for this, and I bought 4 or 5 of them just for this reason, so I'd always have one to replace. So the next thing we got to do is I'm going to check this capacitor here. I did order one, but it hasn't come in, of course. So I'm going to check this one. If this one checks good, we'll crank up and let it run on this until I get the new one. Now this capacitor is a 30 and a 3 microfarad. So the brown wire goes to the fan. It's 3 microfarads. This blue wire goes to the run winding of the compressor, and it is a 30 microfarad. So I'll show you how I check that. It's not really a real professional check, but it's what I do. Okay, power's off, guys. This goes to the fan motor, so I disconnected it. This yellow wire here is common to both capacitors that is built inside of here. So what I want to do is I just want to see if it'll charge. And what that means is this meter should move. I got it set on ohms, the lowest setting. It's on the 200 ohm setting. So what I'm going to do is go across to common and to the fan terminal. Let me check leads. Yep, leads are okay. Common. Uh-oh. Let me reverse the leads. This is what I normally would do. That capacitor is open. So during that power surge or the shorting of the windings, whatever, this capacitor went bad. Well, let's check the compressor capacitor. It's a 30 microfarad. Okay, let me get this off here. Here's the compressor, 30 microfarad. Okay, that one charged. That capacitor's still good. And then going back the other direction, it's good. So, thankfully, I ordered this. It just didn't come in. And like I said, I guess COVID has got the supply chain messed up, because what used to take 3 days It's not taking 3 days anymore. So what I'm gonna have to do now is go to my shop and see if I've got a 3 microfarad capacitor. And I can leave this one for the compressor for now and add in one until my other one comes, till the real one comes in. Okay, I'm back. I did not have a 3 microfarad capacitor. I was taught you could go 20% over. So I'm gonna put these two in series. Whenever you put capacitors, well, resistors in series, you add them. But in capacitors, it divides. So a 7 and a 5 will be about 3. So what I'm going to do is stick this on there temporarily, because I have a feeling tomorrow that other capacitor should come in. It's been over a week. And so there's no kids around here or anything like that, so I can do this. This is going to have to be outside the box because it won't fit inside the control cabinet. So anyway, so what I'm going to do is I'll show you the same test now. So this is going to go to power, and the fan terminal, the fan wire will come here. So think about this as just being one capacitor right here. So what we're doing again is charging the capacitor. We're seeing movement in the meter. Nothing there. Okay, it charged. So this setup right here, I have no idea if these two are good, but now I know these two are good even though they're used. And while I'm on the subject, the next time you hire an air conditioning guy, think about all the parts. He's got thousands of dollars worth of parts on his truck, and that saves a lot of time. I've worked on this air conditioner here, I promise you, 4 hours right now, trying to get all this, going and looking for this, and just getting parts together. It takes forever. I'm not in the business anymore. Hadn't been for over 20 years. So think about that when you're paying that high HVAC bill. Well, there's a lot that goes into it. All those parts, and it's training. The young guys, they're trained on these units. They know where everything is and what it does. I have to go and read it, right? So I'm old school. So this goes to the fan. There's the plug there. So I'm going to plug this in like it's a single capacitor there. And this wire is the power wire. So you see it's coming in here. So I can either plug in here or over here on this contactor. I just plug in right here. Now if all this works, I'm going to have to just tie wrap this in here like this and leave it overnight and hope for the best. I might could put some kind of guard around this to make sure no raccoon gets into this tonight. But we're ready to test. I've verified all the wires except for this rigging here. Everything else, see black on both sides. All yellow wires. This is ICP is a carrier product, and they always have color-coded wires. So it's pretty easy to trace out things. So the high and low are back where they're supposed to be. There's high and there's low on that fan. So we're going to throw the power on and see what happens. Okay, so I had trouble with my thermostat, but it finally called for it. I was trying to catch it pulling that contactor in with the video, but of course I couldn't do it. So I've got the temporary capacitors there strapped to the unit. I'm going to set this guard back up kind of in front of it. But it's running about the right amps, and we can check temperature here. See, it was running 150 or better before. So that's good. We got good speed coming out and no vibration. Well, this is one way to skin a cat. If you have a question that I didn't cover here, just leave it as a comment and I'll get back with you. Have a blessed week.
He wants to dance.
Yeah, he does. Good. Get it. Get it. Get it. Get it. Get it.